Welcome to the Deep Dive. Today we're jumping into a brand new paper that just hit RGPT, and it details a really interesting piece of AI tech called 4D-RGPT. Our mission for this deep dive is to get to the core of it, really.
Yeah.
We're looking at how AI is finally trying to gain what you could call true 4D perception in videos.
Yeah.
So not just what's happening, but where things are and how they're moving in 3D space over time.
And that's the perfect context to start with because, if you look at these big multimodal LLMs, they're brilliant with text and static images, just brilliant.
Yeah.
But the moment you give them a dynamic video, they kind of struggle with what the paper calls weak 4D perception. They just don't have that simultaneous grasp of space and time.
They can't track things properly.
Exactly, and that's the gap, that specific gap that 4D-RGPT is designed to fill.
Okay, let's unpack this a bit. When we talk about 4D here, it's not just, a marketing buzzword. We're talking about the three spatial dimensions.
Length with depth.
Plus that fourth dimension of time, of motion.
Yeah.
And getting a model to understand that all at once is the whole game. So the model itself is 4D-RGPT. It's a specialized multimodal LLM. But the real innovation, it seems, is how they actually taught it.
Yes, that's it. The core idea is this training framework they developed. Perceptual 4D distillation, or P4D for short.
P4D, okay.
And you can think of it like an intellectual transfer. Basically, they take all this very specific, very computationally heavy 4D knowledge from a huge frozen expert model.
Things like depth mapping, trajectory prediction, that kind of stuff.
Precisely. And P4D distills that knowledge into 4D RGPT, but not the massive, expensive computational engine behind it.
Wait, hold on a second.
Yeah.
I hear 4D distillation, and I immediately think there has to be a catch. I'm thinking this must be incredibly slow or add a huge computational spike.
That's the natural assumption, yeah.
Are we sure this isn't just adding another expensive layer that makes it impractical to deploy?
And that's the genius of it? No. This entire knowledge transfer happens without adding any additional inference cost.
So it's a free upgrade.
In terms of capability, yes, you get this massive boost in 4D understanding, but with zero hit to speed or efficiency when you actually run the model. That's the key engineering takeaway here. It makes it useful now.
That's actually incredible. But it brings up another problem. If you've built this amazing 4D engine, how do you even prove it works better if all the existing tests are designed for 2D thinking?
Exactly.
We know the current 3D and 4D video benchmarks mostly focus on static scenes. They don't even have region-level prompting. So the authors realized they needed a better measuring stick, and they built one. It's called R4D Bench.
And this benchmark is laser-focused on depth-aware dynamic scenes. It specifically demands that the model understands things at a region level.
What does that mean in practice? What's the difference?
Well, think of it this way. An old benchmark might ask, what generally happened in this video? R4D Bench allows you to ask something like, see that person in the red shirt? Track them. What was their exact distance from the parked blue truck at the 45-second mark? It demands that granular dynamic reasoning.
Wow, okay. That's a whole other level of detail.
It is. And to make sure the benchmark was solid, they used a hybrid pipeline, part automated, part human verified, to ensure the questions were high quality and, actually relevant.
So the million-dollar question, how did it do? What were the results?
The results are really compelling. On 6 of the existing non-region-based 3D and 4D benchmarks, 4D-RGPT showed a really notable improvement, about a 5.3% gain on average.
A solid gain. But the real test, the one that validates the whole idea, has to be their own benchmark, the R4D Bench. How did it do there?
That's the one that matters. And on R4D Bench, it posted a 4.3% improvement over the baseline model.
Which doesn't sound as high, but on a much harder task.
A much, much harder task. And what's so fascinating is that this result validates their entire approach. It proves the model is effectively capturing explicit 4D signals. It's moving beyond just summarizing a video to actually performing spatial temporal reasoning.
So to wrap this up for you, what you've just heard is how these specialized models are making a critical leap. They're learning to see depth, movement, and context all at once, and without that speed penalty you'd normally expect. It's a much deeper understanding.
Right, and if a model like 4D-RGPT can perceive dynamic regions this effectively, you have to think bigger. This isn't just about better YouTube captions, it raises a really important question for the future. What happens to the safety and reliability of autonomous systems like cars or robotics when their perception moves from just seeing in 3D to truly having 4D insight?